Okay, I am recording today how to use my program, I guess I could call it, for my chemistry project. Basically what it is a variable titration curve that allows the user to change specific variables in any titration from a strong acid, strong base, which you can see down here, which is this tab, a weak acid and strong base titration, meaning you start off with a weak acid and you titrate it with a strong base, and a weak base and strong acid titration, meaning you are titrating a weak base with a strong acid. And you can simply just click these and it'll change to those specific ones. So to start off with, we have a strong acid and strong base titration. And basically anything in yellow, the user can change. Well, any of the numbers in yellow, I should say, are the things that the user can change. The words next to it describe what you are looking at. So this is variable, it's in yellow, this is stuff that I can change. I have the initial concentration of the strong acid, the initial strong acid, and the initial concentration of the strong base that I'm titrating the strong acid with. So I can just type in any random stuff that I want, or if you have any specific data that you want to use it with, maybe if you're planning to do a titration and you just want to have an estimate how long it would take to titrate it, you can type it in. For instance, if I want 0.25 molar of strong acid, so it could be like hydrochloric acid, and I have 0.5 liters. Make sure that everyone knows everything in this is done in all the molarity is moles per liter, or in liters, it's all liters and moles. So I have the initial concentration of 0.5 liters, and initial concentration of strong base is 0.2. I'm going to change that to 0.25 right here. Awesome. And that should change the titration curve right here. As you can tell, I kind of move. Show it again. It is when I do it. Okay. And also up here in this yellow is where I can change the ratio of hydroxides to the protons in the solution, or the initial protons. Basically, for instance, this allows you to change it from when you're using the strong bases, such as sodium hydroxide, which is there is one hydroxide per anion, and magnesium hydroxide when there is two hydroxides per anion. So right down here it says a chemical reaction ratio of H plus to OH minus in the ionic equation. So just gives a little quick example. I have 2HCl plus magnesium hydroxide. That's supposed to be a lower script. Excel doesn't, at least I haven't found a way to put in a lower subscript. That's what I'm looking for. And so in the ionic equation breaks up into 2H plus 2Cl minus plus magnesium 2 plus 2 hydroxides. If you see here, I have it bolded, 2 hydroxides and 2H plus, and just showing up here, the bold is the stuff up here, 2H plus, 2H minus. So right now, what I actually have is 1H plus and 1OH minus, meaning that it could be like a hydrochloric and a sodium hydroxide titration when there's only one hydroxide per and the strong base. So I can change this to be more like the example problem, which is 2 hydrochloric acids and 1 hydroxide, or 2 hydroxides. If you see, it actually changed the curve right here, cut it in half because there's 2 hydroxides per every strong base, so it's going to take less. Anyways, weak base and strong acid are going to be the same thing, except just it's going to be reciprocals of, well, inverses of each other. So I'm just going to focus on one. Again, it's just the variables that you have here that you can change. Everything in yellow you change. Except the only difference with this is that it needs the pKa of the acid. that you're titrating, or the weak acid that you're titrating. And down here also calculates your PKB, your KB, your pH at the equivalence point, so you can just like look at it really quick where that point is, pH-wise, and then the pH at half equivalence points, which is just your pKa. It's the same thing as before. And a little extra thing that I actually have on the strong acid and strong base and the weak base and strong acid is this little box. This does, well, it does what it says. It's looking up the pH from volume of base. So what it says here is plug in volume of base to find pH. All I have to do is plug in a specific volume that I want to find the pH at. So let's say at this point I have 0.4. It should be somewhere around 5. So I'm just going to put 0.4 liters. My pH was at 4.82. I was just guesstimating, so I guess that's about right. Or I can plug in the pH value, so I can look on here, and it'll tell me the volume that it'll take to get to that pH. So for instance, I was saying 5 earlier, where the pH is actually 5 is at 0.477 liters, which is really close to that 0.4. But just to show you again that this should be the same as this, except inverse. I can type in 4.82 for my pH and it should be 0.4. 0.401. This does round slightly, as the warning on here says. So that's basically for the titration curves for the weak acid and strong base. Just to give you an example, I can have an initial weak acid concentration of 0.75 molar, an initial volume, let's just say it's 0.5 liters, and a concentration of strong base, it would be 1. And this would be the curve for that titration. And this is basically the same thing, except the only difference is that it doesn't have the ratio to it. That is right here. Basically because there's already a given amount of hydroxides in the solution, so it doesn't really matter. And this only works for monoprotic acids, so you won't get any 2 bumps or anything like that on any of these. But because there's only a given amount of hydroxide already in the solution, I don't need that ratio. But anyways, it works the same way. So just listen to the weak acid and strong base to get how it works. The only difference is that it's a PKB for the weak base instead of pKa. Virtually the same thing in regard to how the math works. Except everything is 14 minus blah, blah, blah. Okay, I believe that is it. Thank you for listening. Bye.